Hello everyone, my name's Adam. And in this problem, we're going to be finding the values of all 6 trig functions given some initial conditions. And the initial conditions that we have here is that the value of secant x equals -5/2 and tangent x is less than 0 or negative. Now the first thing that we want to do is concern ourselves with where the angle x is in the unit circle. So let's first look at that. So let's take a look at our unit circle. Where we have quadrant 1, 2, 3, and 4. Now why is it important to find where x is at in the unit circle? Well, that's going to tell us what the sign of the trig values are as we go around. So what we know from before, we're using our phrase, all students take calculus, is in the first quadrant, all trig functions, sine, cosine, tangent, and everything else is positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, cosine is positive. Of course, the opposite is true. Wherever a trig function is not positive, it's going to be negative. So if we take a look at this, we're not told the value of tangent, but we're told that it's negative. So right off the bat, that tells us that x, the angle, is going to be either in the fourth quadrant or second quadrant. Now first what we'll do is we'll start by taking a look. Given the function that we do know, secant is equal to -5/2, we can use that to find cosine. So cosine, using our reciprocal trig identity, is 1 over secant x. And we know the value of secant x, and we'll just go ahead and plug that in. So 1 over secant x is 1 over -5/2, and 1 over a fraction is just its reciprocal. So cosine of x is just going to be equal to -2/5. So cosine is negative and tangent is negative. So that tells us that our angle x is in quadrant 2. Okay. So using this, we're going to proceed and find the rest. So we found cosine. Next, let's take a look at, say, finding sine of x. Now I don't have enough information with what I'm given to find sine of x right off the bat, but the fact that I know cosine, I can use one of the fundamental trig identities, namely the Pythagorean identity, that has that sine squared x plus cosine squared x is equal to 1. Now that we know cosine, we can plug the value of cosine in here and solve for sine. So let's do that. So we have that sine squared x plus the value of cosine squared, which is -2/5, is equal to 1. And that gives us sine squared x. Squaring this out, squaring the negative becomes positive, and we have plus, say, 4/25 is equal to 1. Now we want to solve for sine, so we're going to bring the constant 4/25 to the other side, or subtract it. Now to do that, we're going to do some fractional arithmetic. So we're going to instead write 1 as 25 over 25, and subtracting 4 over 25 gives us that sine squared x is equal to 21 over 25. Now, the last thing we want to do is to solve for sine of x. Up here, we're going to take the square root of both sides. Now keep in mind, when we take the square root, we technically need to take both the plus and the minus. But going back to our unit circle, we know that x is in the second quadrant, which tells us that sine is going to be positive. So we're going to take the positive solution of this. So sine of x is going to be positive, say, square root 21 over the square root of 25, which is 5. So next, once we have cosine and sine, we can pretty much do any trig function we want in any order. But now I think we'll do, say, tangent. And using our identities, we know that tangent is sine of x over cosine of x. Okay? And given the values of sine and cosine, we can just plug those in. So sine of x is positive square root of 21 over 5, and cosine is negative 2/5. So we have two fractions being divided by each other, and that's the same as multiplying by the reciprocal of the denominator. So multiplying square root of 21 over 5 by negative 5/2. And we see our 5's here will cancel. So in the end, tangent is going to be equal to negative, say, square root of 21 over 2. Next, let's take a look at, say, cosecant of x. Right. Now, cosecant of x, which we know is 1 over sine of x. And we have the value of sine of x as square root of 21 over 5. Okay. And 1 over a fraction is just its reciprocal. So this is equal to 5 over, say, the square root of 21. Now this answer by itself is fine, but it's traditional practice to rationalize the denominator. So we're going to do that by multiplying top and bottom by the square root of 21. So our answer is going to be 5 times the square root of 21 over 21 for cosecant of x. So what do we have? Cosine, sine, tangent, cosecant, and secant to start with. So we don't have to do that one again. The last thing that we have is cotangent. Okay. So cotangent of x, we can do this one of two ways. We know that cotangent is equal to cosine divided by sine, but since we have the value of tangent, it might be just as easy to take this as cotangent being 1 over, say, the tangent of x. And 1 over the tangent x, 1 over the tangent of x is 1 over negative square root 21 over 2. 1 over a fraction is, again, just its reciprocal. So this is negative 2 over the square root of 21. Again, that answer would be fine, but we're going to rationalize the denominator by multiplying top and bottom by square root of 21. So in the end, cotangent is going to be equal to negative 2 times square root of 21 divided by 21. So there we have it, all 6 trig functions. Thank you very much.